Okay, so let's pick up where we left off. This was the surface that we ended up with in part 3, and I copied it into a new file. Keep things clean on my screen. Here's where we're going with this. Here's your reference file for part 4, and we're going to walk through extracting wireframes and a couple different panelization strategies from that framework. So a couple different options: folded panels that are flat, converting those isocurves with straight end sections, lofting those straight end sections across. You can also try sweeping those across, be a pretty similar result. And then we're going to go through the geodesic short paths, and we'll also talk a little bit about unrolling things with detail. So taking those strips, unrolling them with some idea for where exactly structural sections might intersect, so that when you go through a fabrication, you've got some idea for where exactly you need to maybe put alignment holes or otherwise measurements so that you know how things could align later on. Okay? Okay. First thing I want to do is take these two surfaces and give them a rebuild. And again, I'm going to drop it down, the UNV count, to something like 25 and 10 on my screen. See what that comes out like. And looks nice. So that's as a follow-up to the last exercise. Even though the process of matching that surface gave us a little bit of a gap in the middle, just by rebuilding the two of them, we ended up with a really nice even keel transition from one side to the other, and a really nice wireframe from which to start. We can use this for panelization, and we can also use that for a drawing. It's really quite nice. And let's just for the hell of it, let's just take. So I have a different set of layers here. That's okay. I'm just going to extract that wireframe on the default layer. Just take a look at it. And there it is. And I can type in select. Oops. Hit OK. Select last. Will select all those lines for me. And I can move that in over here. Pretty nice. And for the sake of this exercise, I'm just going to work with half of the form. So I'm just going to select that half and just delete it. And I'm then going to change my default layer to a construction layer, or let's call it the profiles layer again. Stay organized here, and I'll change that color to cyan so that the things that I build into it will look different. And then because I've started to name new layers and I have a bunch of layers I'm not using, I'm just going to type in purge and hit enter, and that's going to get rid of all the layers that don't have any objects on them. It's not such a bad way of working, so that when you start customizing your layers, you're not simply renaming, you're just building new ones. I'm also going to make a surface layer and put these original surfaces on that layer so that I can distinguish between what's old and new more carefully. Okay. Okay, we're all set up. And another layer I'm going to build is the points layer. And I'll just make those, I guess, red. And I'm going to select all of my wireframe lines here and run the intersect command and generate a grid of points as well. I find this sometimes to be a little bit easier when I'm working to snap to points than having to snap to intersections, so long as your O snap at the bottom here with point is clicked on. All right. And then I'm going to make a copy of this, move that back just a touch, and make a copy of all of that action over here. And then we can get to work. Maybe I'll move it just a bit like that. Okay. So the first thing we're going to do in the kind of as an introduction to paneling will be to just simply start connecting the dots. So in my construction layer, I'm just going to go to surface, corner points, which is and it's going to allow you to snap to 4 points to make surfaces. And I'm just going to connect the dots to illustrate how we can go from curvature to an approximated curvature with flat or semi-flat panels. And by semi-flat, I mean that it wouldn't surprise me if some of these panels were kind of twisted, because we're starting with a doubly curved form. But it's a first step of at least getting things to be a little bit more easily fabricated. And you can see that, what I mean by approximation, of course, is that we're taking the curve here and instead building it out now by connecting it with straight line segments that form panels in the end. So that's an approximated curve with straight line segments that then form a series of panels. So this would be one process to go through in terms of panelizing this entire surface with discrete panels, individual panels that exist between all four of these corner points. But because you've got a grid here, you've got the option to do different things if you'd like. You can, first of all, you can draw these out and you can start joining them in horizontal. You can just join them in the horizontal direction. So you end up with long strips that are continuous. Another thing you can do is to ignore some of the points and skip to make the panels a little bit larger in one direction as you see fit. So this is a pretty flexible framework for you to start working. You can see that you can make these large or small as you go. And that's going to just give you different results in terms of the approximated curvature. Okay? So you can go ahead and experiment with that a little bit. But again, one of the takeaways from this, from earlier examples, is how, once again, the quality of the surface, starting with the quality of the line, results in a framework that you can use for further on down the line for things like accurate paneling, or at least proportional paneling to the curvature, and also drawings that will come from that. One more way of working that I did want to show is I'm going to also just click the Polyline command and connect the dots with Polylines. And you can hide or delete the one that you're working with. And let me start that again. And by doing this, and by clicking this through, you're making the straight line segments between. And this might be a little bit of a faster way of working if you want to make a series of separate panels. Instead of doing a little bit of a longer process of selecting all four corner points and making separate surfaces and then joining them later, you can connect the dots across the form. Like this. And then what we'll do is we'll loft these two polylines. And because it's a series of straight line segments, the loft should come out like a kind of a folded ribbon, if you will, or a long surface that is joined together as a single surface, but may actually produce a poly surface for us of separate panels. So let's see how that goes. So we'll loft that together. Let's keep straight segments on in this case, or even normal, just to see what that does, whichever you like to try. And yeah, and you can see up at the top here what it did is it selected a poly surface instead of a surface, meaning that if we go ahead and break that apart and explode it, we'll be exploding it into separate panels. So it's maybe a slightly faster way of working, although as you can see, in some cases the loft ended up giving me some pretty weird results. So that's something to watch out for. I think in that case, we should go back, undo the explode, and maybe let's try to do the loft with straight sections to see if that fixes it. Maybe we can also align the curves. Maybe not. Let's see if that, well, yeah, okay. Well, maybe we're finding a limitation here with the loft, where it's giving us some pretty wonky results. In the reference file, that was one of the ways that we did this here to make these. And you can experiment a little bit with how that works with the reference framework and compare that to what we currently have now. In any case, just another route for you to take and try out. But I guess connecting the dots with 4 corner points, especially in this case, doesn't take too long. Okay, let's grab this, let's move this maybe back over here as one of our tests, and we'll grab the one just prior to that and bring that over, our original framework. And now I just want to change the first one around here. So I'm just going to delete that and connect this with straight segments, individual straight segments like this. And I'm going to do that also on the other side. Okay, individual segments like this. Right. And this here, again, you can use sweeps. Here's a nice way of using sweeps along the curved rails with straight sections. We'll give you also ribbons that could be, I think, unrolled into long strips that could be, built out of wood or another material, depending on how you're building this thing. So let's go ahead and do the sweep 2, using those 2 rails, of course, and our cross-section curves at both ends. And we're making really nice surfaces here all the way across. Curve, curve, cross-section, cross-section. Oop, looks like I did that wrong, so let's try that again. Second rail, curve, okay. Nice. Another way of skinning it, going across. Straight section, straight section. And let's take a look at how this unrolls here. Explode, no. Okay, and by unrolling that, using the unroll command, you can see that the unroll in this case is well within a tolerance in inches, which is quite good. That means the deviation that was required to make this flat surface is so small that you shouldn't run into major issues when it comes to applying this to the framework to which it's attached, if everything is built properly. So that would be one of your straight strips that you can start applying and kind of bending into a framework of wood, kind of a structural framework, a skeleton, if you will. Okay, so there's another option. And maybe while we're here, I want to revisit that loft command. I'm going to select 2 curves instead and just try straight sections. That seems to do it much better than how I did it before. Yeah, and that's going to give us the same result as the sweep in this case because it's so controlled. Before, what I did is I drew these polylines out thinking that it was going to give me an even breakdown, but in fact, in this case it didn't. So I could simply do the loft, straight sections turned on as an option, and get that surface to come out a little bit more cleanly. Of course, the difference being what I was after here was separate panels. Here what I'm after is long strips. So in that case, it doesn't work for separate panels, but it does work for longer strips. Okay, so just to clarify the use of the loft in that reference file. And let's try another option that is an interesting one. We're going to try to draw geodesic paths across the surface. So in this case, what we actually need is, we need a couple things, but we definitely need the surface. So let's grab the surface from the start here, pull that over to a workspace, and then let's extract the wireframe. Okay, so extract wireframe, and there's that. The other thing that I'll do, and we're going to need basically with this command, let's take a look at our reference file. What we're going to need is a set of points on one end and a set of points on the other, basically from start to finish. So we'll have to get we'll need to tell the command where you want the line to start and where to end, and then the surface that you want to draw across. And it's going to find the shortest line across that surface, okay, between those 2 points. So let's put a set of points, and I'm going to go to my points layer for this, at the intersections of that wireframe we just drew. And I guess and so go ahead and actually start on the other side and then count how many you have. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So we're going to need 8 points over here. 1, 2, 3, 4, 5, 6, 7. And let's find that eighth. It's a little bit hard to see. It's going to be somewhere here, and we can probably ignore that one because it's at the bottom. Okay, so we're pretty much ready to go. We could also, we could probably at this point now get rid of that original wireframe. So what I'll do is just lock my surface layer and my points layer, and just kind of put a window over that and delete that wireframe that we used just to draw the points. Okay, and I'll head back into my construction layer. Actually, yeah, go ahead and stick with the construction layer for now. Okay, and to draw the geodesic lines, we'll use the short path command. So type in short path. The surface is going to be that one there, of course, the original surface. And then we're going to click the start of the curve at the top point and the end of the curve at the back point. And the shortest line across is going to be the top edge, which is probably not too surprising. Let's try again with the next 2 points. And keep going. And what you'll see is that those curves are not along those isocurves anymore. Because what we're doing is drawing the shortest line, not necessarily the best line to show curvature. And this is a little bit more like how certain kind of traditional boats were skinned, where the boat builder would figure out a way of basically laying the material across the frame, and if there was a frame, but laying the material across and figuring out its shape through a trial and error process. And kind of carving it back and cutting its edge profile in order to assume the curvature as best as possible. And let's just wrap this up here. We'll bring this one over, and we'll do that last one too, just in case. Because what I'm going to do now is use this as a way to start splitting that surface up. And we could either, you could decide on whether or not you want to use the split command and use these surfaces, exactly these, as a way to start developing your strips. Although I don't know if I recommend that because there's still double curvature in this. So what we're going to do is lock the surface layer and bring over the stuff we just drew as a frame. Okay, like this. And we're going to take these now and loft these as straight sections. You could even sweep these with a straight section up front. So we can try a couple different options. First, let's do a loft. So I'm going to loft these as straight sections. There's one. And I'll try this one as well as a loft. There's two. And let's try also the third in the middle here, just to see if how they match up nicely. Yeah, pretty nice. And they're different shapes, which is also interesting to note. The other thing we can try is a sweep. So I'm going to draw a cross-section curve at the front and the back and see how that turns out. So sweep 2, your curves are going to be your rails. You can also use surface edges to make sure that they match, which is pretty smart. And it looks like we're getting very, very similar results between the sweeps and the lofts. Okay. Very nice. Also interesting, what I'm realizing here is if I use, let's run that sweep one more time. This one here was swept, and I'm going to do another sweep. And instead of selecting the curve, I'm going to select the surfaced edge, as you can see there. And now what it's doing is it's forcing the isocurves to align, at least in some areas. So let's try that again with this surface. So first rail is going to be the surface edge. Oops, I forgot to draw my cross section. Let's try that again. Very nice. Sweep 2. First rail is the surfaced edge, and we'll just select the curve and see how that goes. Yeah, so now what we're doing is, the lofting before actually gave us some things where there were some very different isocurves being drawn across. In this case, we're matching them because we're using the surface itself as an input. Okay, so that's a good thing to note, especially if, again, you're going to be producing drawings from this or using these lines somehow productively, either to make structural sections or whatever. Let's take a look at the unroll for this. All right, and we'll draw that over. I'm just going to bring it over for reference. Just take a peek at it. And yeah, you can see that it kind of flares at the front here. It comes in at concave and then maybe flares out a little bit there. Whereas the next one in line is going to be quite different. All of these are within a kind of area tolerance, which is quite good to see. And here we've got a couple different strips that would hopefully, when we align these to our structural frame, would do a nice job of that. Now, one thing to keep in mind, of course, is that we're not modeling material thickness, and we haven't yet even modeled our structure. But you know, so there's a lot of process there to make sure that the structural frames are mitered or even cut right to the angle of the curve of the boat, so that when you're attaching these panels, they attach flush. Of course, that's some modeling that needs to be done in that case. But there's also some other details that you can do to kind of make that process a little bit simpler physically, you know, in the making process. But in any case, let's walk through our last part of this kind of surfacing example, which is going to be to unroll these with a little bit of information, with some data. Okay. All right. So I'm just going to work with, I'm going to move this one over a little bit to give me some breathing room. And I'm just, oops, looks like I had that layer locked. Yeah. Let's move that over. Cool. Okay. I'm going to just use a different layer. And I'm going to use this top curve here, and I'm going to divide it. Okay, so let's divide this top curve a certain number of times. Let's not do it 50 times, maybe just like 10 times, just to give us some points. Okay, and we're going to use these points to draw some cutting planes. And they won't be. You can refer back to exercise 1 to do this a little bit more appropriately, but just for the sake of argument, I'm just going to draw a cut plane straight on, basically down from this point, from the perpendicular direction from the top curve. So once again, let's type in line, perpendicular. You might remember this from the first one. Select that point. Make sure you're drawing this out from the first point. Hold shift and just draw that out like that. And let's do this a couple times. Perpendicular, start, F, shift, line. And you can do it 2 or 3 times. I guess I'll do it 3 times here. P for perpendicular, starting point, F, shift, out. Okay, cool. Head into my construction layer, and what I'm going to do is just extrude these. Extrude these curves downward a bit. Like this, just down. And I know that they'll intersect like that. Okay, let's make a new layer, call it sections, make that layer red, it'll be easier to see, activate that layer, and let's find the intersection between these 3 planes and the surfaces that we just drew. So just type in intersect with all that stuff connected, and yes, you're going to get a couple of cross lines going across at the seams. We don't actually need those, so we can just delete them. And what we have now is a segment here, a segment there, and a segment there. I'm just going to focus in on, I'm going to delete this one just to keep this a little, you know, to make that really clear in terms of what, you don't have to do that. I just wanted to show you that these were separate line segments. Okay. All right, and I'm going to put a point, go to my points layer, and I'm going to put a point at the either end of these sections. And this. Okay. The other thing I'm going to do is go to, I'm going to make a new layer called dots. I'll make that one white or light gray, something like that, and activate that. And what I want to do now is start naming and tagging things. So if this is my, let's call this the third ribbon or the third section, and I want to figure out exactly where each one of these sections is going to occur along it. Before I do the unroll, I can start tagging things and adding information in my 3D model. So let's type in the dot command, and this is something like this is going to pop up. I'm going to change my font size to something a little bit smaller, like 10, and I'm going to call this C or 3, whichever, which would be my naming convention here, and you can make up your own, but my naming convention here will be to first label the actual strip, and then after that, the section in space. So I'm going to just call this 3_S1. So 3 section 1. And I'm going to put that right in the middle there. And I'm going to do that again and say 3S2 and 3S3. And those are 3 sections that occur along this plank, the third plank. And let's see what happens now when I do an unroll, selecting all of that stuff along with the surface. So let's unroll the surface. Let's click it. And let's also click the lines. Let's click the points. And the dots. And let's see how that goes. Yeah. So if you run the command, what you'll get now is that stuff coming through with the surface itself. So the things that you select that are relative to the thing you're unrolling can be brought along for the ride. And I'm just going to rotate that to make it a little bit more. Yeah. And I'm just going to move that over so we can take a look at it on screen all at once. Yeah. So here we have, and one thing that I didn't do is leave the source layers on, but that's okay. But you can see the lines here are now drawn in 2D along with the surface profile, so that when I go through and start laser cutting this or setting up my files for laser cuts, I can direct my bolt holes or whatever it might be, or at least even just a score line, or maybe it's just a drawing that you're lining up to your full size or your full scale cut piece, so that you know how things should align later on down the line. Okay, so you can use this way of working to coordinate all the pieces of your construction to all the pieces of the 3D model, which will not only make for more accurate drawings, but also good templates and a base from which you can start digital fabrication to get all those things to align. Okay, so that kind of wraps us up here. For this exercise,